Hello, everybody, and thank you for joining us back here at Pressure BioSciences channel. We're sitting here once again with CEO Rick Schumacher. And Rick, previously we talked about your past, how you got involved, the whole origin story of the company, so to speak. But today I want to dive deeper, give us an overview of the company. How are you doing? Are you ready to get into it?
I certainly am.
Perfect. So for those not quite aware, can you just give us a basic elevator pitch of what it is Pressure BioSciences does?
We're a company that makes instruments that we sell into a lot of different industries. All of our instruments are based upon the use of high pressure. Pressure is an amazing force of nature. Pressure moves at the speed of sound. There aren't a lot of companies in the business that we're in because really we're one of the first companies to ever figure out how to safely control high pressure. When I talk about high pressure, I'm talking about pressures that are 2, 3, 4 times the pressure at the bottom of the deepest part of the ocean, which is called the Marianas Trench. We hear about the Marianas Trench and 6, 7 miles down. Imagine City, you and me, Michael, sitting down there having this discussion with 7 miles of ocean on us. We can get that type of pressure in a millisecond, and we can control it. We can go to half that pressure, a third of that pressure, 1/100th of that pressure. Pressure is an amazing force of nature that it controls a lot of things in the laboratory, a lot of the molecules that we have to work with as scientists. And we use heat and we use pH, we use chemicals to control how reactions work, to start them up, to slow them down, to kill viruses. But now we can use pressure because pressure can do many of the things that temperature and chemicals can do, but it can do it very quickly, very accurately. And once you're done with it, you press the button, the pressure's off, and you're back to normal, or what we call equilibrium. So we make these instruments that are sold to scientists all over the world. They are academic scientists doing research. They're industrial scientists that are in pharmaceutical and biotech companies that are developing the next line of diagnostics, the next line, I hope, of products, of therapeutic products that will be used by you and I and our families to have a better life. We can help them make these products by using machines that are based upon pressure because of the advantages that it has.
Interesting. There's definitely a queen under pressure joke somewhere in there. But anyways, Rick, if we could at this point then walk me through the platforms you guys are currently working with.
We have 3 technology platforms. We have a total of 30 issued patents so far. The 3 platforms are called pressure cycling technology, or PCT, barrelfold technology, or we just call it barrelfold, and ultra shear technology, or UST. So let's take the first one. We started the company based upon pressure cycling technology. As the name says, we cycle pressure. We turn pressure on and off. 2 reasons we do this. Number one, we can't patent pressure. Pressure's been around for centuries. It's been used, can't patent it. But we are able to patent cycled pressure because that's something that's really never been done before. We had to develop the instrument that could actually turn pressure on and off, high pressure on and off. In my first couple of months of doing this, without the help of Dr. Edmund Ting, who's been with me ever since, we paid about $30,000 to buy these pressure machines, and we blew them up because, like many people, it takes quite a bit of knowledge to understand how to control that pressure and control it well. So the machines just kind of broke. They got worn out very, very quickly. Since that time, I hired Dr. Edmund Ting. He's a pioneer in the area of using pressure, particularly in the food industry, killing bacteria and microorganisms and making food safer. But Dr. Ting came on board, and knock on wood, I'm superstitious, so I got to be careful what I say, but we haven't lost a machine because of the use of high pressure. It hasn't worn out a machine since, and that's been 15 years. So you got to surround yourself, as we talked about before, with people that are brighter than you, smarter than you, particularly in certain areas. And I've done just that. So with pressure cycling technology, it's all based on exerting pressure, taking it off, like squeezing a sponge. We squeeze cells. Imagine having a cell. It could be a bacteria. It could be a cancer cell. We squeeze it back and forth until it breaks. Everything in nature that is biological has a pressure point. Once we know that the pressure point of this virus is 10,000 psi, let's say, and this other bacterium is 20,000, and this cancer cell is 30,000, we can dial that pressure into the machine, and we can exquisitely break that cell, that virus, that bacteria, that cancer cell, that normal cell, to release those incredible molecules that are inside it, on it, and inside it to be studied, the DNA, RNA, protein, and the lipids. And so once you've decided that, you can exquisitely break open cells And you can actually break open several different cells by going to different pressures once you know what the pressure profile is of each cell. So we have 325, actually 350 pressure instruments. They're called a barocycler, baro for pressure, cycler, because we cycle pressure on, off, on, off. We have 15 issued patents, and we have about 200 customers all over the world that are using this barocycler instrument because they can exquisitely break open the cell of their choice and release those macromolecules to study to look for the next cure, the next best diagnostic. That's pressure cycling technology.
Yeah.
Second one is barofold. Baro, again, for pressure, fold for folding. Very simply, when many new drugs are protein-based, many new drugs are based on protein. Remember 30 years ago, Mike, drugs were all chemical, and they're just not very good. You know, a lot of byproducts there, and then they're not very efficient, and they're certainly not very specific. Nowadays, more and more drugs are being developed. I read the other day that over 50% of drugs in the coming, this century, this decade, in fact, will be protein-based because they're very specific. They can go right to the site and bind with it because that's what proteins do. Proteins are made up of amino acids that are long strings, and they fold over each other to form the protein. And the exact way they fold gives the protein its activity. It's like a key in a lock. If the key doesn't fit, isn't right, it's not going to open the lock. The protein has to have an exact formula of rolling over itself, folding over itself. So if you're making a protein in a lab as a drug and it gets misfolded, which is what happens when you make a lot of protein in a big vat in a lab. Sometimes the proteins fold incorrectly. It won't work. In fact, it can be hurtful. It can be deleterious if it's used. When that happens, pharmaceutical companies have known for years they can use pH, they can use chemicals, they can do a lot of things. It takes time and money. Pressure can do many of those things to fix that misfolded protein in the lab. And we have 8 patents that do this. So we're now working with 6 companies. 3 of them are multi-billion-dollar, multinational companies. 3 of them are startup companies that are well-financed. And they've run into problems with a protein that they think might be the best next drug. The problem is when they make it in the lab, it unfortunately has this inherent ability to misfold. When you exert pressure a certain way, we can unfold and refold that protein. So now it's exactly the way it's supposed to be. We fixed the problem very quickly, very efficiently, very inexpensively. We have those patents, and we're working with certain companies that have proteins that could actually be the next billion or multi-billion-dollar drug, but they're having problems with the misfolding. And we can sometimes fix that with pressure. And we own all of the patents that I'm aware of in the world for fixing the misfolded proteins. The third technology, which we're very excited about, is, and I'm sure you can tell I'm not excited about the first 2, but the third technology we have is the one reason we're excited about it is because unlike the first 2, which have a wonderful future, they're going to take time, and we do a couple of $1 million a year already in those 2 technology areas, but it's going to take time to build them and get them into the mainstream of science. The third one is more manufacturing, and we don't think it's going to take much time at all because we fix a major problem, and a product it becomes a very good product when it can fix a major problem. There's a major problem in that many of the drugs that we're developing are based on active ingredients that are in oil. Many of the nutraceuticals we take, the vitamins, the supplements that we take are oil-based, like vitamin D3 and CBD, and many astaxanthin, a very powerful antioxidant. Many of the chemicals that we use for crops are oil-based, essential oil and other oil-based. Many of the foods that we have are oil-based. If our bodies are water-based, so when we ingest or use a topical substance that's oil-based, we don't absorb a lot of that active ingredient out of the oil because our body wants to get rid of the oil. Well, we've developed a method using pressure that actually cuts the oil drop down to nano size, very, very, very small, smaller than a bacterium. So we break the oil into billions of nano-sized, what we call droplets. and the active ingredient, let's say it's CBD in CBD oil, or let's say it's vitamin D3, that active ingredient inside the oil gets dispersed among a billion tiny little nano-sized particles. Now, when you ingest that or rub that on the skin, you get what's called much better bioavailability. The body, because of the very large surface area, is able to very quickly reach into the oil and pull that active ingredient out and utilize that active ingredient. So when you think about the problem, when you're taking a pharmaceutical or you're taking using a cosmetic or using a nutraceutical and it's not being absorbed well, you're not getting all of the full effects. In fact, it could be absorbed less than 10 or 20% of what's in there could be absorbed. The rest of it's being excreted by the body. We break the oil down the right way. We break it down using physics. We actually shear it through a patented valve that we invented, and it shears it into these tiny nano-sized particles. And it's been shown over and over and over again that these called nano emulsions are extremely stable and extremely bioavailable. And they're also very water soluble, so they get transported through the body. So we're very excited about that because there's a huge problem, whether it's in the CBD field, the vitamin field, the pharmaceutical field, getting active ingredients out of oil. We solve that by developing a nano emulsion that's long-term stable, that's done the right way by shearing it, by cutting it into these tiny little nano particles of oil.
It's really interesting, Rick, in terms of the sheer size of potential customers that last one has. Not saying, as you said, not saying that the first two don't have a lot of applications in specific industries. That last one, ultra shear technology, seems like it could be utilized across so many different industries. Seems like you guys have a very large potential customer base.
It's very large. I'm not the youngest man now, but I would normally say that even if I was 20 years old and running this company, I'd say there's probably more customers and more applications than I could ever do in my career if I ran the company for the next 45 years. And that's exciting stuff. It's exciting because it is truly a platform technology. I used to say to people, it's like inventing electricity 180 years ago. And you have this thing you call a light bulb. And somebody says, yeah, it's a one-trick pony. That's what you got, this electricity, and you've got one product called a light bulb. And then, of course, now we know there's tens of thousands or hundreds of thousands of products that run on electricity. We've invented a way to break oil down to nano size to allow the active ingredient in the oil to be absorbed by the body, whether it's a human or an animal or a plant, far more efficiently than it is ever absorbed now. And we do it through we have now 7 issued patents. We're excited because we're going to be releasing this product in the next, this year in 2022. We've already made announcements that we'll be commercializing ultra shear technology. Our partner is Ohio State University, one of the top. They have a College of Food and Environmental Science and Agriculture, and it's one of the top in the country. Some people say in the world. They're our partner. We have a consortium, a 50-50 partnership in a consortium. We have an instrument in their very well-known pilot demonstration lab, and they're going to start inviting companies. Some of the top companies, if I ask you to name the top 10 beverage companies in the world, they're probably going to invite them to come visit. And they're also going to invite a lot of startups and everything in between. That's hundreds, if not thousands of companies, to invite them to come in and use it and try it and let them know that it's available for licensing in the very near future. So yeah, it's pretty darn exciting right now.
Yeah, it sounds like we're going to have a lot to talk about over the course of this series, as I had said previously. And guys, I again implore, if you have any questions about these, don't be afraid to ask. We will in the future do specialized videos on each of these and get you guys some more updates over the corner ASAP. But for now, Rick, thank you so much for coming on again, and have a wonderful day.
I'll do that. You too.